Now, generally when I make videos about how to make a particular compound, I'll give you a whole bunch of videos. So we're actually going to lump all the amine videos into one set of reactions because honestly, by this point, you have a good feel about how to make most of these compounds. I mean, you're kind of going to get it by association. So one of the things we talk about early in organic chemistry is this cyano substitution of alkyl halide to give us the nitrile functionality. Well, I don't really need to put a whole video on that because you kind of already know how to do that reaction. So this video is mostly going to focus pretty quick and dirty on how to make a whole bunch of different amines and advantages and disadvantages. So let's build on that first one. Let's say we have an alkyl halide, Rx, and we can add potassium cyanide or some type of cyanide source to this. Now, major limitation of this technique is that one, you are going to be adding an extra carbon when you do this type of reaction. So your amine is actually going to end up on this carbon, but it will be a primary amine and it will be attached to a secondary carbon. That said, if this R that it's attached to is not a tertiary or secondary carbon, you do run the chance of having rearrangement. So please check out the earlier videos on cyano and nitrile functionalization of alkyl halides. Now, what we're going to initially form is this nitrile group, and then if we use a reducing catalyst like hydrogen over platinum, we can get the R, CH2, NH2. So this is one way of doing it, but let's say we don't want to add the carbon. Well, an analogous reaction is to use sodium azide. And the sodium azide here is going to give us the azide functionality, and again, using a reducing catalyst, we'll produce that as a result. Another option, let's say we have something like benzene. Well, benzene we can't directly functionalize with nitrogen. And the reason we can't directly functionalize it is that we need something that will undergo electrophilic aromatic substitution. We don't have that option. This is NH2 is too rich. So we're actually going to use aqua regia to form the nitro group, and then further reduce this to give us the amine. So here are three ways you can produce it. Now, there is another way, and this is something that I haven't talked about in historical videos, and this is an epoxide. So let's say we make an epoxide. And the advantage of this is that if we do use the epoxide, we're going to end up with an alcohol. Well, we can take our epoxide, and as long as we have a solvent that is protic or allow us to do this, we can do NH3, and the NH3 will actually add in an anti-fashion. So this is just something to keep in mind. Now, it will be nice because you generate that alcohol functional group, but that alcohol functional group will be anti, in terms of rotate the bonds, anti-conformation to the NH3. Now, the last option we have, and this is talked about more in another video, is we can make the amide and reduce it. So if we have a ketone, we can add something like a primary amine to this. And the primary amine does not actually react to produce an alcohol. What it actually produces is the amide. And we can subsequently reduce this with a platinum catalyst to give us our desired secondary amine. So these are just a few of the ways that, building upon previous examples, we can talk about how to make amines from other organometallic reagents. So again, take this list down. This is more kind of adding to your synthetic skill, but hopefully you can see how this builds on the previous material that we've covered in Organic 1 and Organic 2.